Hi all. So today we'll be continuing with our divide and conquer strategy, and in that we'll be learning about quick sort. So quick sort can be considered similar to the merge sort that we learned previous, but here the only difference is that you are free to choose your pivot point. What is pivot point? Pivot point is the point through which you can divide your array into left array and the right array. Okay. Generally, you can consider any point, but mostly it's taken the last point. Clear? So let's say if we consider this as our last point, then what we have to do next, let's say if we have kept our 8 here, anything which is less should be placed in our left side, and anything which is great should be placed in our right side. Okay. Once we have this left side and right side, then again the same strategy will keep on following for this part, that is left side. Again, we'll take this last element as our pivot, and we'll again apply the anything which is left and right, we'll keep the pivot in center, and this thing will follow here. Same thing, it is going to follow here. Clear? Okay. So on brief, we have understood what's actually happening. Okay, so the logic seems simple and even the code is simple. Let's try to do it practically step by step, and we'll try to compare it in graphical format also. So let's go with the first step, that is creating the quicksort function. Let's say public static. Do I have to return something? No. So I'll keep it as void. Okay. And after void, the function name is, let's say, quick sort. Okay. Great. What are the arguments it's going to take? It's going to take the argument as int array. So let me give it array. Then it requires the starting point and the ending point. Okay. So you can give starting point like, let's say, int low, comma, int high. So these are the two index that we want. Once we get this, what should be done? So again, here the merge sort logic, what was the base condition? The base condition here will also remain same, that in case if ever low is greater than high, in that case, we do not want to apply our quick sort. So here the condition will be something like, if low is less than high, if this happens, then only apply the logic that's going to be done. Clear? Okay, sounds great. So what is this function? Like if you see, remember our recursion, how we have discussed, like quick sort, like you can consider it as a black box. Anything which you pass like array, low, high, it's going to give you a sorted array. So that's what is going to happen. Okay, now how actually it's done? So we have to call this quick sort once for the left side and once for the right side. Clear? Okay, sounds great. But there is a slight issue, that is we need to know this P. Like for example, here I have said, now how will I get to know this point? Right? So for that, first we need to let's find out these arrays, like this part, and then we have to again find out this part. Clear? From this part, we have to pass on to our quick sort the particular index, right? So what I can do for default here, I can write let's say quick sort once I have to call, and one more and once more I have to call the quick sort. So once for left side, one for right side. So these are the two times we are calling it. But before that, I need to find out the point, right? So for that, I'll create one more function. Let's say the function name is like partition, which is generally called as partition. So let's say this function will give us that particular point. So I can say like int pivot index. Okay. It is going to be provided by partition. Let's say partition. In which, what is the argument for partition? It requires the array. Okay, so which will pass. Then we are going to pass, let's say, the low point, comma, the high point. Clear? Okay, we have not yet defined our partition, but in general idea what it is, this partition function will give us the points. Okay, like the pivot points. Now let's define this partition function or a method. Like what we can say here, public static. Does it need to return something? Yes. If you see here, it requires the int type return. So here I am going to say as int. What is the function name? Partition. Clear. What are the arguments? The argument is int square bracket array, comma, int low, comma, int high. Clear? Okay. Once that is done, now what should happen inside? So while discussing initially what I said, by default, every time, generally we take the last point as our pivot. Okay, you can choose any point, but for starting, we choose like last point as our pivot. So similarly here, what will happen is that we have to first declare our default value. So I can say int pivot equal to like whatever is my array bracket high. Okay, what is high is the last point, the highest point I can say. Clear? This will give me the pivot. Now, what I have to do? Clear? Like okay, there might be a slight confusion. Like if you already know this pivot high, again, why are we requiring this partition? The thing with this partition function is that only for the first time, you know that your pivot is going to be this 8. But next time when you are recursively going to call this quicksort function, that time you don't know where your like array is going to split, like which point will be the exact pivot point, okay? Because there will be left array as well as right array. So for that purpose, we require a function in which initially, like for the first time at least, it is considering as high. Next time, whenever you pass any array, let it be left array or right array, what it is going to take, it is always going to take the last index of that array as the pivot. Clear? So that is what it is said here, array hat. Then what I'm going to do is I'm going to create a pointer. Let's say the pointer is int I equal to low minus 1. Why low minus 1? So this I pointer will act as a target, like a pointer to our elements. Okay, in case if it is small, then it is going to place it at the left side. In case if it is let's say greater, it is going to swap it to the right side. We'll see how it is. For default, like for the first time, what will be its value? For the first time, its value will be -1. So it will be like pointing towards like what we can say, the negative index, which is not a valid index. Only when the condition is being hit, that is when it is less, that time we are going to update its value. For example, let's say here I'm iterating to my entire array. So here I'm going to say for int what I want is j is equal to low, okay, colon, and go up to like j like less than high, okay, colon, and do j plus plus. Okay, fine. So what does this for loop do? This loop will start with our starting index, like it is going to iterate through our entire loop. Okay, why didn't I say 0? Because we are like not sure like which array is going to be passed. For the first time it will be 0, but let's say when right array is being passed, that time low will be something here. Clear? Okay, so once the loop is started, now I'm going to put the condition here, like if my array, just a second, caps lock, okay, if array of j, okay, is less than, let's say, pivot, okay, that means for here, for the first time 8 is the pivot, array of j is what, let's say 12, and in case if it is less, now is it less? No, this is not less. But if you see here, 4 is less. So in case if 4 is less, what we are going to do, is we are first going to increment our I. So we can say I plus plus. Then what we are going to do is we are going to swap. What we are going to swap? Let's say we are swapping, we are first passing array. We should swap the ith position with j position. So what will this swap? This will swap 4 and 12. Okay. This is for first time. When it is continuously being called again and again, the values will be changed. But for the first time, this is the pivot. First time, nothing will happen when our loop starts. For the second iteration, it will this condition will be hit. When this condition will hit, what it is going to do, it is going to swap 4 to the first place and 12 to the second place. That is what this step is going to do. Clear? There is no valid swap function, so we need to also define that. Clear? Okay. So what will happen till here? So this loop will start from here and will iterate up to 15, let's say. Okay. And anything which is lesser will be automatically placed to the left side. Like whichever is lesser than 8 will be automatically placed to the left side, and all the greater numbers will be to the right side. But 8 will be still, that is our pivot, will be still at the last. So to make this last element in the middle, here we have to write a last swap thing. So swap. Here what I have to swap is, I'll pass the array. I have to swap the I plus 1, comma, the high. These are the index value that I am passing. This is for what? This is for swapping the pivot, which is putting it in middle. Okay, this is what is happening here. Once this is done, now what I am going to do is I'm going to, let's say, return what I'll return, whatever is my I. Just a second, insert I plus 1. Okay, clear. Now, why I plus 1 here? Because let's say we have been sorted still here, let's say 7, 3, 1. Okay, all these are swapped, swapped. These are in the left side. Here, no matter if they are jumbled still, we are not worried of that. We just want whichever is less than 8 will all be at the left side. Okay. Once these are at left side, this 12 will be at here. So it will be 12, 15, something like this here. Okay. So let me replace and show you. So this will be, let me cut it from here, Control X. Okay, I have enabled NVim, so it's a bit different here. Okay. What's my point is that these all will be in left, and this 12 and 15 will be here, and 8 will be here. So what we want the 12th one to be replaced with 8. So if you see 12, I is what? I is 1. I will be 1. We want 12. So we'll say whatever is I plus 1. That's what is being said here. And that will replace the 8. Okay. So from here, what we are going to get is the middle 8 value. Once this is returned, so here what we are going to get is the pivot point, which is 8. So whatever is the 8 index, that index we are going to get. So next time what we are going to say, quick sort low. Low is still, it will be like 0. But this high should be what? Whatever is my pivot index minus 1, right? Whatever is my pivot index. Insert mode. Just a second. Insert mode. Okay, whatever is my pivot index minus 1. Yeah. Similarly, for right side, this is the pivot, pivot index I'll get. And I want the low to be changed here. So that will be pivot index plus 1. Pivot index plus 1. Clear? Okay, so this completes our entire logic, but only thing is that we have not yet defined our swap function, which is pretty simple enough. So here I am going to say public static. Do we need to return something? No, right? We need to just swap it. So it's public static void what we are going to get, we are going to get, let's say first one. Okay, we are going to get, let's say int, square bracket, we'll get array. Okay. Then what next we'll get? We'll get the 2 pointers that we need to swap. So that will be first int I, comma int j. Okay, these are the 2 pointers. Now here what I'll do is I'll first create a temporary array in temp equal to array of I. Okay, fine. Then what I'll do is, let's say array of I should be equal to array of j. Okay, once this is swapped, then I want array of j, okay, to be swapped. Let me remove this m from here, to temp. Okay, to be changed the value. Yeah, so this is a simple swapping thing happening here. And yes, so that completes our quick sort. Okay, so a brief idea like what's happening. Let me clear the screen and let me first check if it works fine. So let's run. Okay, the issue is that I didn't display it and I neither called it. So let's call the quicksort function. Let's give a proper tab. Okay, let's call the quicksort. We are passing array, low is 0, and what is high? High is whatever is my array dot length minus 1. Clear? And then I have to iterate through the loop. So I can say for int num colon array, curly brackets, enter. Out. I want in the same line, so just print, and what you print, just print num. Do a spacebar in between, and yes. So if I run it, so if you see, it has been swapped. Clear? So this is working completely fine. Let's try to check once again how the logic is working. Let me select the pen. Clear. So here our function starts. We created a array. Okay, fine. We called this quicksort function where we passed this entire array. We passed the 0 value, that is the initial value. Then we passed the final value, that is the length of the index, like this index value we passed. So from here, it goes back to this point. Now, when it comes to this, it gets the array, it gets the low, that is 0. And whatever is the last index, it gets the last index here. Clear? Then here, the if condition, by default, the first time at least it is not going to be hit. When this condition will hit, only once it's recursively being called, there will be a point where due to -1, +1, the low will be higher than high. So to avoid that, this will be used for, but for the first time, it's the condition will not be like violated. So here low is high, so this is correct. So we'll enter inside this. And here what is happening is we are finding out the pivot index. So that why we are finding out the pivot index, so that we can break our entire array. Okay, let's say entire array into 2 parts, which is left array and the right array. Clear? We already know that by default, what we consider, this is our pivot. So we know that this is our pivot. But here we can't divide it, right? We can't have left array here and right array here. So what we do, we take the 8 here and we place all these items which are less. Like for example, here it is 4, 5, 6, 7, 3, 1. Here the order does not matter. Just they should be less than 8. And here it should be like, let's say 12 and 15. Clear? How this is done? This is done with the help of here. Like if we see here, we are passing the array, we are passing the low, high. What we did here, we are passing the 8. So 8 is being passed here. Then what we said, by default, we said it is -1. This is for only first time. Do not again get confused. So for the first time, it will be -1. And here what we are doing is we are iterating through our array. Okay, let's say we are iterating through our array. And anything which is less than 8, okay, what we are doing is we are placing it here. Oh, so if you see, we are generally just swapping it. Okay. So if you try to break this down, how actually it's done is like, if you see, so first time, let's say this is our original array, 12, 4, 5, 6, blah, blah, blah. So it will just do swap 4, 12, 5, 6. Then again, it will do 4, 5, 12, 6. It will keep on happening. And the final value which it will get is like after this complete for loop. After this complete for loop, the array will look something like 4, 5, 6, 7, 3, 1, okay, 12, 15, 8. Okay, this is what the array will look like. So if you see anything which is less than 8, anything which is less than 8 is like partially divided, and everything here is left like less than 8, and everything here is greater than 8. Okay, now our only task is to put this 8 here. So if you see here, this function like swap, what here it does, what is I now? Presently, the I will be this. So we are going to say I plus 1. So it will be pointing towards this, and this point and this point will be swapped. Okay, the swap function logic is pretty simple. And once this is done, we are just returning this 8 index. So this index value, whatever it is, we are going to return this. And then from here, what will happen? You will get this part as the left array and this part as the right array. Then the same logic applies. Now for this, you will consider this as your pivot. And again, you are going to pass it. So everything below less than 1 will be placed here, and everything above this will be placed in right array. And this thing will keep on happening. And thus, at last, you will get it in the sorted form. Clear? So if you have like watched my recursive video, so in that, how we discussed, just try to think this as a black box. Just make sure like it's working for your final logic. Okay. Then here internally, it will take care of its own. Okay, cool. So that completes our this problem. Let's move to the next one. Okay. So here is our next question. So the question here states that we have an array which is in a sorted form, but in a rotated form. For example, let's say we have array like 1, 2, 3, 4, and 5. If you see, they are sorted, but what has happened with this array is that they will like take a point, let's say this point, 4 and 5, they'll place it, they will rotate it. So this will be somewhat converted into like 4, 5, 1, 2, and 3. Clear? So what is this array? This array is sorted and in rotated form. Plus, all the values here are distinct. Okay, that means you do not have duplicate like 1, 1. These are not present. There is only 1, 1. Yeah. Okay, so what we got to know, there is a array which is in sorted form, but in a rotated format, and all the values are distinct. Okay, clear. What is our target? Our target is to find a particular index of which value we get. For example, if the value is provided as 2, then our target would be, let's say, whatever is the index of this 2. So that will be like 0, 1, 2, 3, 4, 5, 6. So we should get the output as 6. Clear? Now, it seems simple, like you can just use a loop, like let's say a simple for loop, and you can iterate through all of this, and the one which is matching your value, that particular value, you are going to return it. Clear? But the concept, like for if you use a for loop, then the time complexity will be somewhere of big O of n. That means you have to iterate through your entire loop. So we should find out a way where it's taking less time than this. So somewhere log n log n. Clear? So how can we do this? So again, there comes the logic of divide and conquer. Okay, so let's try to see how it is. So let's try to first put this in a graphical format, so it's better to visualize. So let's say if this is our array, like any array, if we plot it on x and y axis, this is how it looks. So it's in a sorted form, like it will start with 1 and go up to 5. Clear? This is the original array. Now, in case if we break it, let's say I break this and I put this part here, like then how this graph will be converted? The graph will be converted somewhat like this. So our starting point will be this now, starting index. So it will somewhere start from, let's say here. Okay, it will end here. And then if you see the ending point, where is the ending point? Like this, again, this one is somewhere like it will come here, which is continuation of this. And again, it will go up to like this. Clear? So if we split the line, this is what we are going to get. We are going to get line 1, okay, and line 2. Okay, so what we did, if we originally plot it, it's a simple straight line. If we cut it and paste it like at the end, then this is how it looks. It will start with like starting index and the ending index is somewhat before this itself. Okay, this itself is going clear. So now we have to figure out what is our index. So how is this going to help us? So let's imagine they provide us any value. Okay, so this value can lie in 3 places. What are the 3 places? Like okay, let's break this down still further. Like it can lie in just 2 places, like 2 lines. Okay, what are the like it can either lie in line 1 or it can either be in line 2. Okay, sounds great. In case if it is in line 1, let's say in case if it is somewhere here in middle, there are again 2 possibilities for line 1. That is, it can fall in this range. Okay, so the first one is from starting index to the target, we can say. And the second one is what? From target up to end. Am I clear? So what do I mean by target to end? That is nothing but this entire. Yeah, this is the second case in line 1. Yeah. In case if it is in line 2, let's say if it is line 2, let me plot line 2. Now again here there are 2 possibilities. One is it can be in this region. Okay, this region. What is this region? This region is whatever is the mid, we can say, like mid or target, whatever you consider, like mid to line 2. Okay, or it is known as ending point, ending index. It can be in this form or from starting index up to mid. Okay, even this I can name it as mid. Here as well, I can name it as mid. So what we are going to get, like for example, if I draw it once again, so if it is in line 1, it can be either in this part or it can be in this entire part. Okay, where even this line is included. In case if it is line 2, then if this is the line 2 and if this is drawn here like this, then it can be in this part. Okay, or if not, then the entire this part is what it lies. Clear? So once we get this, we have to keep on like using the recursive function and keep on finding, like breaking the line in between as they are in sorted form, and we'll get our final value. Okay. So as usual, we'll try to code it so it will help us in better understanding. So let's try to code a little bit. So let me click A, enter. So I'm going to, let's say for now, I'm going to create a target. So int target is nothing but the value what we want is equal to, let's say we want to search for 0. What is the index of 0? Okay, fine. Then what I'm going to do is I have to first create a function. So let's create the function. So the function name is, let's say, public static. Do I need to return something? Yes, I need to return the integer value of that index. So int, let's say it is search. We are going to search it. Now what we are going to search is, like before that, what we are going to get the argument as int array. Okay. What else? After getting the array, we need the target, like what index we want of that particular thing, right? So we require int, let's say target. And then we need the starting point. So I can say int starting point or starting index, comma. We also require the int ending index. Look, okay, this is fine. Now, once this is done, again, here the concept is same where we did for previous two. That is, we are going on dividing this our left array and right array, right? And usually when you are doing in this format, the base condition is almost like always same. That is, if my starting index is ever greater than ending index, what you do is just return. Look, return with what? -1. What do we mean by -1? That there is no particular value present there. Clear? Okay, once we have done this, now let's try to find out the possibilities, like find out the places where it can be there. First of all, the most simplest thing is that whenever we divide our array, in case if the target and the middle part is same, then we can simply return from there. We need not do all this recursive thing. So let's first find out the mid, by the way. Int mid equal to whatever is my starting index. Okay, I have said you, like we can do it in this form. Like we can say, okay, there is one way, that is starting index plus ending index divided by 2. Or there is one more part, like first find out the difference, that will be ending index minus starting index. Look, divide this. Divide this. So you will get the range. Divide by 2, then you will get the half of the range. Whatever is the half range, plus it with starting index. Okay. Yeah. You can use the first approach also, no issue. Like just you have to make sure like you are dealing with small arrays and not with large complex arrays. Okay, it will just increase the int value log. Okay, so you may get some error, or you can follow this concept, which is a better safe. Now, once we have found out mid, we are first going to check like if the mid is the same value. So I am simply going to say if array of mid is equal to let's say target. If this happens, then I am sure shot that whatever is the mid index that I have to return. So return mid. Clear. Okay, this is done. Now what we have to do is, if in case if it is not there, then what we have to do is we have to check first for left line, like line 1. So I can say if it is line 1, what I have to do is come inside this. First of all, write the condition for line 1. So that will be somewhat like if array of starting index, okay, starting index is less than or equal to array of mid. Okay, so this will somewhat come into line 1. Fine. Then what you have to do here, you have to again check for two cases, like is it in this range, for example, which color, like is it in this range? Where is the line? Yeah, is it in this range or is it in this range? Like here again we have two cases, right? Even in line 1. So that's what we have to write here. So it will be like if array of starting index, okay, starting index is less than or equal to target, and what it should be, like target should be less than and equal to mid. Okay, less than and equal to mid. Okay, what is the mid? Like the midpoint is, so if you see, this is the midpoint, right? This is the midpoint. So we are writing the condition for this side. Clear? Okay, if this happens, then what you do is first of all complete the proper syntax. Okay, then what you do is call the recursive function for like return search, which is our function name. The array will be same, target will be same, starting index is same, but the ending index will be what? Whatever, like mid minus 1. Clear? Okay, fine. In case if this is not there, then obviously it will be in the other part. So for else, for that, what you do again, return, call the recursive function like search, and here you give array target, and here the starting index will be changed. It will be like mid plus 1. Clear? Okay, once this is done, do the same thing for the line 2. So delete this and enter Z. Okay. Here else, I can write it here, like I can give a first comment. So saying that this is in line 2, and here I can write else. Okay. What should happen in else? Again, there are two conditions. That is one from mid to ending value. So first, let's write the condition for that. If my array mid value, okay, fine, is less than or equal to target, or target, and uh, okay. So what I'm doing, if array of mid is less than or equal to target, okay, and it should be less than the ending index. So it will be like target should be less than the array's ending index. So EI. Okay. Then in case if this condition is true, what you do is call a recursive function that is search array tar starting index ending index. What should be changed is the starting index. So that will be mid plus 1. Okay, fine. Now, in case if this is done, then what you do is else search for return, call the recursive function for array target. Now ending index will be changed. So this will be like mid minus 1. Yeah. So this completes our logic of what is this sorted and rotated array. Let's make sure we are calling this function here. So here I can say int target index. I'm going to get the tar index. Let's say tar index equal to the search function. Okay, I'm going to get array target, and okay, here it should be 0, and here it should be like ending index should be like array dot length. Array dot length. Yeah, and put a colon. Once the target index is found, let's display it. So I can do south, enter, and I can simply print tar index. Okay, looks great. Let me clear this image, and okay, let's test it. Run. Okay, what I can do is open the terminal. Okay, so if I try to rerun it, so run, and if you see, I'm getting the index as 4. So let's try to search for 5. I should get it as 1. So I have to first change the value here, like replace with 5. So delete 5. Okay. Oh shit. Okay, fine. So let's run this. We are getting it as -1. So there's a slight issue. Let's see what's the issue. So in search array target starting index ending index. Okay. Then mid ending index minus starting index divided by 2, array mid target return mid. Then in case if there is left array of starting index target and okay, this should be array of mid and not just mid. Let me append array of mid. Okay, and then return search array target starting index mid minus 1. Search. Okay, let's check now. It's returning as 1, and if you see it's in one place, let's search for 2. Let's put it 2 and let's search it. Yeah, so if you see it is returning 6. So just try to make sure like you are updating here correct. We are actually checking with the element and not with the index value. So it should be array of mid. Clear? So this completes our problem of this sorted array, rotated and sorted array. Clear? Okay, cool. So that's it with today's class. Let's see in next class. So let's catch up in next class. Bye.